Alrighty, good evening everyone. We're just going to get started here in a few minutes. Just wanted to get everything rolling. Make sure y'all can hear me and see the screen. I've got the latency set, so there may be a little bit of delay for the chat, but I will try to keep up. But this is my first time streaming, so we'll see how that goes. Have to say this has been quite the adventure learning all these different tools, different everything. This is going to be a lot of fun. Well, alrighty. Welcome to the last session of How to Do Map Stuff for 2020. Hopefully this is the first of many different years of doing this. Big shout out to Daniel Huffman for organizing all this. This has been a great chance to kind of reach out and really engage with a lot of people. It's been amazing to see all the different live streams and people from all over the place. Huge shout out to anybody who's from New Zealand or Australia or somebody out there in the Pacific or Asia. I know we're finally in the morning for you guys, where a lot of these were early morning or midnight. So if we've got a couple of you on board, welcome. So like the title card says, we're going to be talking about terrain. So as we all kind of do our check-in and say where we're from, I also would invite you to say what your favorite mountain is or your favorite canyon. We're going to be talking a lot about Utah because that's where I grew up, and you haven't seen enough of it today yet. I've seen a lot of southern Utah, but for me, mountains and canyons really speak to me. Sometimes, a good mountain is worth its weight in gold. So as you kind of check in, I'd invite you to say, what's your favorite canyon? What's your favorite mountain? What speaks to you when you think about nature? So with that out of the way, let's get started. So just a little bit brief background. My name is Jake Adams, like I said. My day job, I work for the Utah Automated Geographic Reference Center, the AGRC. We aim to be really the premier GIS team in the state of Utah. We collect, clean, merge data from all over the state, counties, cities, just really everywhere that we can find to create statewide data sets. We maintain this and publish it in the State Geographic Information Database, the SGID. We've been doing this for, I think, 36 years now or something. So we've been around for a while. It's a really great group to work with. You can find us online at gis.utah.com, or we're on Twitter at @maputah. So that's what I do during the day. After work, I really like to cycle, but that's not the point of this. I also really like to do cartography and cartographic coding. A lot of times at work, I don't have the opportunity to work on the maps that I really want to work on, so crazy person that I am, I come home from work and go back to work making maps. You can find me on Twitter at GIS_Jake. I've got a very randomly updated blog at gisjake.blogspot.com. And you can find a lot of my code on GitHub at github.com/jacobdadams. So let's start talking about why we're going to talk about terrain. And terrain plays a very large role in understanding both our human world and the natural world. We start to say, why are things the way they are? And I really got into this. Pull up this. It seems to be the day to show off, our first thing we did in our intro to cartography classes. This was mine in Dr. Brandon Plue's cartographic design class at BYU. And this is a map of the Hurricane, Laverton, Tokerville, and Leeds area in southern Utah, right outside Zion National Park. If you've ever been to Zion, you drive up this road here from Vegas, or if you're coming from Salt Lake, you come down this road, turn here, and you go into the park. Now the assignment was to kind of make a street map, almost like an old phone book style map. And I kind of argued back and forth with Brandon Plew about this a little bit because I really wanted to show terrain. If you've ever been down here, you know that terrain is a huge part of why this area is the way it is. You know, why does this road make this huge loop? Why split the city at the river? Although a lot of cities do that. Especially, what is up with this road? I mean, the west is, you know, it's based off of the PLSS, the Public Land Survey System. Everything's square. So why is it curving? There's got to be something about that there. And we look up here in Tokerville, you know, it's a very linear city. Why is that going on? What's going on there? So we turn to terrain for answers. So we're going to look at a couple different ways that we can show terrain on our maps, whether it's the star of the map or just a supporting layer. So to give a brief overview, first off, I want to talk about the tools that we're going to be using. I work primarily in ArcGIS Pro, but I also work primarily with the command line GDAL tools, or GDAL. You know, who knows how you pronounce that right. But you can also work in QGIS because the GDAL tools underlie, is the library underneath everything in Q, and I suspect a lot of things in ArcGIS as well. One thing I want to mention in ArcGIS is Esri has provided a really great tool set called Terrain Tools. If you look it up online or look at it on the resources page that I linked to in the description of this YouTube video, you can go down there and download that, and that does a lot of really cool things that we're not going to have time to touch on today. Some really neat different ways of representing terrain. If you've ever been to Kenneth Field's Esri UC presentation on terrain representation, he demos a lot of those tools. One other tool that we're going to use today is something that I wrote, and it's called raster chunk processing, and it does a whole host of different things, all sorts of different things to manipulate rasters, and we're going to use it for a couple of cool things at the end. So the different tools, the different topics that we're going to look at here, we're going to look at where you can get your elevation data. Then we're going to look kind of at, you know, some basic hill shades. We're going to kind of rebuild some of this hurricane map, but with some better ideas. We'll use some basic hill shades. We'll go into some of the modifiers you can add on top of a hill shade. Now, if you didn't catch John Nelson's presentation earlier today, I highly recommend you go back and watch that, because he covers a lot of the methods and techniques that we'll use in terms of transparency and layering layer upon layer upon layer upon layer to really get things going. I thought I had a proclivity to add lots of layers, but he had like 20 different elevation layers. It was awesome. So highly recommend you check that out. We might take a pause for questions depending on how our time is doing from then. And then we're going to look at Skymodeling, which is my favorite tool right now. Again, if you hit the earlier session on Blender, it's very similar to that, just a little bit different, different technique. So, without further ado, let's dive into the sources. Not going to hit on this too much, but if you're in the United States, the USGS has a lot of really great data sets. They have a 10-meter DEM and a 30-meter DEM. I use the 10-meter a lot for a lot of my statewide and anything larger than a city. They've also got all their 3-dep LiDAR, the LiDAR that's been collected as part of the 3-dep program, available for download. And huge shout out to Rick Kelson in our office, who does a lot of hard work organizing that and getting these extents set to capture. We are really looking forward to all this great new data that comes in through the 3-dep program. So thank you to everyone who makes that program possible. If you're looking for worldwide or global data sets, John Nelson used the STRM, Shuttle Topographic Radar Mission, data earlier, and there's also the Aster GDM, which is data from the Aster satellite, and I think those are at a 30 or a 90 meter resolution depending on where you're at on the globe. One other source that I have found is the Open Topographic website, and they have the raw LiDAR data as well as some elevation data for all of the USGS's 3DEP program, plus any other data that they can find that's publicly available. So they've got a lot of really great random projects here, there, and everywhere. Interesting, they've also got a lot of really great coverage in New Zealand, and if anybody from New Zealand is in the chat and can explain what's going on there, that'd be great. But it looks like they're being pretty progressive in the LiDAR that they've got. So, yeah. Have I missed anything? Do you guys know of any other better elevation data sources? Please shout out in the chat if you've got those, and we'll all kind of learn together here, because that's really what this day is about, is learning together. Once you've got your elevation data, you need to do a couple things to kind of prepare it and get it ready. And we're going to be using the Google tools to do this, but you can also do it in ArcGIS Pro. So let me kind of pull some stuff up here really quick. So in ArcGIS Pro, if you've got a lot of different terrain data sets, you can pull them in and create a new mosaic data set. And you can pull in a bunch of different tiles of terrain data, and it'll pull it together, and any ArcGIS tools you run against it will run just fine. You can also export that as a single TIFF or whatever other format you want. Now in the Google world, what we'll use is Google Build VRT. VRT is basically a virtual raster, and it's just like that mosaic data set. You feed it a bunch of different files, and you get one file on your hard drive. It's only about 200 or 300 kilobytes, because it just references all those other rasters. And then you can use other tools to export that as a single TIFF file and do whatever you want with that. So that's what I use to combine all my rasters. You're also probably going to need to reproject them. One of the biggest errors that I had early on in my data was I would use elevation data where the vertical unit and the horizontal unit were not the same. Often you get elevation data and the vertical unit is in meters, but if it's using a geographic coordinate system, your horizontal unit might be degrees. And the way the math works, it expects a one-to-one relationship between those units. If it's off, it looks really kind of crazy. You're like, oh my gosh, what did I do? I broke it. And that is usually the cause when your units are not the same. So you'll want to make sure that you're keeping your units the same. You can use either, again, some of the built-in tools. If you're working in QGIS, it's all going to be here in the raster. And I'm just going to run something here really quick. If we warp, which is what you do to reproject, you'll see that we're running under the hood the Google Warp program. So everything I do in the console is what's underpinning a lot of the QGIS tools. So that's basically where we're after. So let's go and look at a map we're working on. So this is that same area from that very first road map. Hurricane, Laverton, Tokerville, Leeds. And yes, it's spelled hurricane. I say hurricane because I'm Utah. It's a thing. We need some terrain on this map. We need to really show what's going on. Now, the basic thing that you're going to do is you pull your terrain in, and we look at this, we think, okay, so there's that, and we need to make a hillshade out of that. So let's go into our folder, GIS, elevation, examples. And I'm going to use the Google DEM tool to create a hillshade. Google DEM, hillshade, livestream.tiff, that's my elevation raster. And I'm just going to say hillshade.tiff. Now don't worry about following all these commands. There is a reference linked at the end to show all this, or again, just do it in Q. One thing you'll have to do is manually add overviews or pyramids, and we'll use the Google Addo program for that. Read only, hs.tiff 24816. And now, if we go into Arc, we can add that hillshade. And it's going to think for a minute. And the way hillshades work, if you're not familiar with them, is it basically looks at the direction the terrain is facing relative to a light source. And we usually always put the light source up here in the top left corner because of the way our brains work. And we put it at about a 45-degree altitude. And so if we come down here, we start to get a better feel for this map already. You can see, oh, that is facing the sun, so it's shaded, or it's bright, and this is not facing the sun, so it's dark. The important thing to realize is it's not actually casting any shadows. We're not shading anything. Now, we've all seen this, and I'm honestly not a huge fan of this hillshade, so we're going to do something better. And this is, in the Google tools, we can give the combined flag, and just do hillshade combined. And this will create a different hillshade that I think looks a lot better. And I honestly think that this is what Google uses for their terrain view. So combined, we'll create those. Refresh this. And already you can see, we can see a lot more here. If we zoom in, a lot of those grays have gone away. If we swipe away, you can see the difference here. It gets rid of the grays, which really cause a lot of problems in, if you're ever layering over colored polygons like different cities or different zones, it really muddles those colors up. So we get rid of a lot of that gray. And the combined hillshade works by taking into account the slope of the area as well. So you can see that, again, those slopes do turn out really well. Especially if we look up in here, that really looks a lot different. And if we go over in Design National Park, I mean, this place is kind of crazy anyway, so we're not gonna I'm not gonna say much more about that. Now, what we normally do once we've got this is we're going to create a hypsometric tint by assigning this a color ramp. And I've got one I've already created. Yes. Calculate. And let's give this a 43% transparency. And there we've got our basic hypsometric tint, basic elevation. So that's what we've got going on there. But I want to add a little bit more to this. We've got a lot of different things we can do here. Now, in his presentation earlier, John Nelson touched on adding slope. So I'm not going to kind of go over that, but I've got a slope layer here. We're going to change this symbology, flip it around black to white. And let's make this guy. Again, the ability to add transparency here is probably one of the biggest things that Pro gives us. If we just add that, suddenly we get a little bit more definition in some of our areas. And I'm going to just swipe this away. You can see how it's kind of outlining the cliffs. It's a little gray in there. One thing we're going to play with a lot, or that you can play with a lot, is change your min-max values here. There's a comment in here, the Google combine equals the multi-dimensional hillshade. I haven't played a ton. You can find that in the ArcGIS terrain tools. I've tried to play around with a little, haven't got the same thing. There is in the Google DM command. There is a multi-directional, and it looks, at least the Google output, looks very similar to the hillshade, the normal hillshade with lots of grays. So I'm not quite sure under the hood what's going on there, but let's go back here. 954%. I don't think we're hitting any slopes near that, so let's give this 100. And that gives us slightly different values. So I'm not going to dig too much into this, but you can see the difference there. Now, another really cool thing that we can do for kind of giving a little bit more data is something called the Topographic Position Index, TPI. Now, again, this is something that you can't, there's not really an out of the box tool in ArcGIS to do this, but Google DEM will do it. It's the Google DEM TPI command. And what TPI does is it tries to basically classify if something is a ridge, a valley, or just kind of flat. So let's add one I computed earlier so you can kind of see what it's doing. And you look at this and you think, oh, there is a lot of really great texture here if we could get rid of those grays. So we'll go here, go symbology, and I'm going to add a stop in the middle and just turn this all the way down to 100% transparency to really get rid of those grays. Now, that's kind of strong. That doesn't look all that great. So let's give the whole layer some extra transparency. Just tone it down just a little bit. And now you can see we've got a little bit more, toned it down too much. We've got a little bit more detail in here. And we can play with the min-max here. What happens if we do 1%? Yeah. So you see it gets very wrinkly, and that may or may not be the look you're going for. You can see what it does up here on the ridges here, these extra little shades of white. May or may not be a look you're going for. I used it on this map here to do kind of the tops of the ridges here. You know, this is a very monochromatic map, and I found a setting that worked really well here. If you've ever been to Zion National Park, outside the visitor center, there is a 3D printed map, or a 3D map that's painted of the park, and you can't help but rub your hand across the top. Everybody does it, and it kind of wears away the paint and you get white on top, and that's what this kind of reminds me of. So again, just a cool little visual technique that you may or may not use. Oh, time flies on this thing. The next thing I want to look at is texture shading. This is really cool. This is something Leland Brown brought forward at NASIS, I think 6 or 7 years ago. A couple people have discovered it, or not discovered it, but used it and published things on it. Daniel Huffman's got a how-to. Tom Patterson has a how-to. Again, Tom Patterson, I'm a huge fan of his work. I got a lot of my ideas from some of the stuff he suggested. Also Tom Nelson, John Nelson, sorry, mixing up those two names. So what we get with the texture, I don't have overviews built on that. So if we turn it up to 11, we get something like this. And Tom Patterson describes how to use a slope mask to kind of show these details only in certain areas. But again, I'm going to go here and let's again get rid of basically the same thing we did for TPI. Get rid of those, and let's just pull these down while I'm here to 50%, 50%, because that's really strong. Ooh, that's still strong. Let's pull the whole thing down. So if we pull that down, now you can see we've got some really nice texture, especially in the flatter areas and in these ridges. Again, I'm just kind of throwing stuff on here. This may not be a look you're after, but this is one of your options for adding a little bit more detail. So just take a second to look at the chat here. Let me know if you've got any questions. Looking at some of these areas. Sounds like I'm a little quiet. I apologize for that. We've got Canyons of the Escalante. Love that area. Dark Canyon, San Juan County. A lot of Utah. I love it. Okay. I'm going to spend the last little bit looking at sky models. Now, sky modeling is a really cool technique to really bring depth. Sky models takes things from basically a cartoon 2D image to kind of the CGI 3D effect that we're all used to. And to illustrate this, I want to show you some pictures. These are some pictures I took of the mountains near my home. This is the mountains at midday, and you look at that, it's kind of a wall. It's just the mountains are there and you've kind of got a wall. This is what it looks like at sunset, and suddenly you start to see the depth in those mountains. You can really see where the different valleys are and little gullies. You can see depth in between the different peaks. Again, midday, sunset. Like, oh my gosh, you can see the canyons, whereas that's just a wall. And one more for kicks and giggles. Compare that to that. So that's what we're going to do with Skymodel, is bring these shadows in. Now we've already seen this with Blender earlier today. This is kind of a different way to do it. Doesn't require Blender, and it keeps things geo-referenced. It probably takes a lot longer than Blender to run. So, you know, different tools, different tasks. To do this, this is first put forward by Kennelly and Stewart in 2012. They wrote a program and kind of detailed how this works. And it basically, with hillshades plus shadows, you add them all together and you get some really cool stuff. So to do this, you use this program they wrote to basically define your sky. And you can see you can move the light source, you can move it up and down, and you can change the different types of shadows. If we have a uniform lighting, we're not getting a ton of shadows cast. But if we change to, say, turbid, you can see we get very dramatic shadows. So what does this look like when we generate it? Well, here is the overcast sky model. And you can see very dramatic, maybe a little bit too much, but it looks kind of like a general hillshade. But if we go to our turbid, throw this on, way too dramatic, but we're actually casting shadows here. If you look over here, you can see, like, look at this ridge. You can tell that's in sunlight, and this whole canyon is in shadow. So I'm going to take that that turbid layer, and again, symbologize. I'm going to pull this down to about 80% transparent, or 20% transparent, because I still want the shadows, and I'll pull the light down to 80% transparent, and that'll give us just some slight highlights on the ridges, because we look for shadows and we look for highlights when we try and figure out the 3D-ness of an image. And then let's turn that down a little bit to about right there, and I'm just going to turn the slope off. And suddenly the image really starts to pop. We start to see the canyons. We can see this river gorge. And if you've ever driven over it, that's, you know, a good 100-foot drop there. We can see this bench, and we start to say, why is that the way it is? We see these mountains, and they look like mountains. If we compare this to this, you can really see the difference that adding these shadows makes. I'm just going to slide away here so you can see that difference. One really cool thing that we can do with this, because this is a georeference layer that we can throw on top of things, let's take this and put it on top of our reference. Now what this does is it casts shadows over all of our reference data, and it makes it look like the things that are on the ground are actually on the ground. They kind of follow the terrain. So if we look at these lakes here, you can see that this shade of blue is different from there. It's being shadowed. Now I've used this in a couple different maps. This was my first map that I created on this, and this I really wanted to show the depth of these glacial valleys, these glacial canyons, really kind of give that depth. We can also see really well here how this road follows the ridge. Now otherwise it would just be kind of floating on top, and it kind of ruins that very artistic 3D effect. Now another one, and some of you may have seen this floating around, I've talked about this a lot. I've really toned it down here. The last one was turned up to 11, and I've printed this out and I took it to someone, and they went up and they tried to touch it because it looked like it should be popping off. And that's what sky modeling can really do. That's what the shadows really do. It really opens your eyes and really gives you some really cool look to your scene. Again, let's look at Echo Reservoir. You can tell that there's a steep cliff there because that side of the reservoir is shadowed. You can see the depth of the Cottonwood Canyons because they're in shadow. You can really start to see a normal hillshade of the Salt Lake Valley looks kind of flat, but you can see all these different benches here that were carved by the river over the years. So, I guess to sum up, there's a lot of really cool things you can do to show off the terrain on your map, to really, show what the area looks like. I hope that you take away from this that there is a lot of different things you can do, and that you don't have to really make these flat kind of crumpled tinfoil maps. There's a lot of different options out there. So thank you for attending How to Do Map Stuff. It's been a great week. Thank you to Daniel for putting this together. Thank you to everybody who has presented. I have learned a ton. I hope you've learned a ton over the day. Just wow, what a community we've got. Thank you for everybody who's stuck together, stuck with us. I know that Jeopardy is on, at least around here, so I hope you liked this better than Jeopardy. If you want to see more about what we've done here, I've got a gist on GIS, or excuse me, on GitHub that kind of explains all the things that we've gone over, links to all the different tools we've talked about. It's in the description, or just go to my GitHub page, gist.github.com/JacobDAdams, and look for artistic terrain resources. I can be reached at GISJake on Twitter, and you can reach AGRC at MapUtah on Twitter. Thanks, and have a fantastic evening.